Hello students, welcome to the Old Time Biometry Show. Today I want to show you how to do logistic regression. We have a problem where the x variable is body weight of caterpillars, and then they're exposed to heat shock, and we see if they end up dead or alive. And so dead or alive is our dependent variable. So the first thing you want to do is graph it. We want to make a box plot. Of course, you could do this in the vertical direction, but let's see if we can make a box plot that's oriented correctly. So you go to Graphs, Chart Builder, click on OK. I'm not sure what that's all about. Then you go to Box Plot. It's this simple box plot thing. You can drag it here. Now, we don't want it to be oriented this way. We want it to be oriented the other way. So if you go to Basic Elements and then hit Transpose, it fixes it all up. And then let's see here. We want body weight to be down here, and we want dead or alive to be there. So then you click OK, and it makes a graph. The graph is not beautiful, so double click on it, and then start fixing stuff. So like for instance, we could fix this, this axis here. And we want it to start off at, let's say, 15 and go up to, let's say, 35. Apply. That makes it a little bit better. Then it just gave you this gratuitous title, which I'll get rid of. I'm sure you could make it much more beautiful. But anyway, that's good enough. And then you could cut that and put it in your report. Okay, now we're on to doing the statistics. We want to see if this pattern could be by chance alone, or do we have confidence that these bars are higher than these bars, that is, larger body weight confers greater ability to survive heat shock. And so we can do that with a logistic regression. We go to Analyze. There's several ways to do a logistic regression in SPSS. We could do it in generalized linear models, but let's do it inside of regression. So inside of regression, we go to binary logistic like that. The dependent variable is whether they're dead or alive after heat shock. Body weight is a covariate, and then you just click OK. And you can see here this omnibus test. That's the test of interest, the 11.029. That's g squared value, the deviance g squared value, and it has 1 degree of freedom, and it yields a p-value that is equal to 0.001. It also gives you some r squared-like values. These are not the ones that are in my book, but you get the general idea. You could report one of those r squared values. And then down at the bottom here, it gives you the equation for the logistic curve with the constant, which is sort of like a y-intercept, being negative 2.901. And then this other constant from body weight, which is sort of like the slope, is 0.566. It also gives a significance test on that, but this significance test is not as powerful as the omnibus significance test, so you'll want to report the omnibus significance test. That's it for the simple logistic regression. Good night and good luck.